Hello, welcome to this video mini lesson introduction to correlation. Correlation is all about the association or relatedness of variables. In other words, it looks at the degree to which variables vary with one another or co-vary. It can be used to explore relationships between variables and also to predict what a case will be on one variable based on what it looks like for another variable. With correlation, we always have to be on the guard for spurious, which is an appearance of a meaningful co-varying relationship between variables, but it's really not. And we have to remember that correlation does not equal causation. So two sort of examples of this. One is the classic example of the relationship between number of storks and number of births. Numerically, where you have higher rates of storks, you have higher rates of childbirth, but those are not really related to one another in any sort of meaningful way. And then my favorite example comes from my 3.5-year-old, who one evening when she was riding her bike in the garage as a storm came in, recognized that every time she rang her bell, there was thunder. Therefore, she felt that the ringing of the bell on her tricycle caused the thunder. Obviously, we know that's very spurious association and that the correlation of the bell ringing certainly does not cause the thunder. It's important to note that correlation is used in post facto inquiry because correlation is really about looking at the sameness of variables with respect to how they vary. So as one increases in value, the other one will increase in value, for example. Whereas experimental studies are looking at actually differences. They're looking at differences between, say, the control group and the treatment group. So correlation is done with post facto inquiry, but not really with experiments. There are a couple of strengths of correlation. First of all, the two variables that you use in correlation can be measured differently. So they can be on different scales, such as SAT versus GPA, but they can also be completely different types of scores, such as number of meals eaten as a family and SAT score. Also, you can do correlations with different levels of data. The past statistical procedures that we've looked at have required at least interval data, but you can do some forms of correlation with ordinal and even nominal data. And it's important to note that there are a variety of different types of correlation procedures. One of the things that's helpful to do is to create a scatter plot of your data whenever you're looking at correlation, because the scatter plot can demonstrate relationships between your variables. And here are some different relationships that we'll talk about. But it's important to note that with correlation, when you create a scattergram, you put the predictor variable along the x-axis and the outcome variable along the y-axis. So here in this first example, we have what's known as a positive correlation. As we have an increase in the predictor variable, we have an increase in the outcome variable. And that's represented by a line with a positive slope. Here we have the opposite. As we have an increase, an increase in the outcome variable is related to a decrease in the predictor variable. So here we have a negative slope, which is an example of a negative correlation, or what's known as an inverse correlation. And that's kind of the opposite, so to speak, of a positive correlation. Here we have an example of absolutely no correlation. There's no discernible relationship amongst these cases, amongst these two variables on these cases. Here we have an example of what's known as a curvilinear relationship. And curvilinear relationships can come in all sorts of different shapes and sizes, but the point with the curvilinear relationships is that there are indeed curves in the data as opposed to correlation which deals with linear relationships. I also want to talk about the difference between direction and strength in correlation. Direction refers to whether you have a positive slope and therefore a positive correlation, or a negative slope and therefore a negative or inverse correlation. You also have to look at the strength, which has absolutely nothing to do with the direction. Here we have actually a stronger correlation than we have here, because all of our cases are more similar and are therefore closer to the line of best fit with regards to the relationship between the predictor and outcome variable. Here we have more variation or more dispersion away from the line of best fit. So in other words, there's a less strong relationship between the predictor variable and the outcome variable. So keep in mind that direction is one thing to keep in mind when you're talking about correlation, but the other thing is strength, and there's absolutely no relationship between the two of those. And also remember, when you're talking about correlation, we're not comparing samples. In our past statistical analyses that we've been talking about, such as independent samples t-test, as well as ANOVA, we've looked at whether or not there's statistically significant difference in your samples or levels of a sample on a dependent or outcome variable such as college readiness. That's very, very, very different from correlation, which is actually looking at how two variables vary with one another. So in this particular situation, we have our predictor variable being the amount of rigorous coursework in high school, and our outcome variable being college readiness. And as you can see, there is indeed a positive correlation between these two variables. But we're looking at the same cases or the same sample here, and we're looking at the matched pairs for each sample, the matched pairs along our predictor and outcome variables there. This is the end of your Introduction to Correlation video mini lesson. If you have any questions, please let me know.